softwares to design, and we don't know the basics of these things. Okay, structural softwares, most of these computer aided design softwares are garbage in, garbage out. If you don't know the basics, then you may run into trouble with your designs. Okay, so that's the importance of this class. We'll just be doing touching the basics of structural design. Okay, so we'll be heading into the course now. So I'll be sharing my screen. Let me share my screen. Okay, if you can see my screen, kindly send a thumbs up. Okay, so we are going into the course. Like I said, this is an introduction. So we are going to be giving a little basics on what structural design is and how to use it and how to derive your design structurally. Okay, so what is structural design? Structural design is the process of creating a framework or system that supports loads and withstand external forces, ensuring a structure like a building or bridge remains stable and functional. Now think of it like a building. Now you need a strong foundation, balanced distribution of weights and materials that can handle the stress. So now in a nutshell, this is what structural design is about. It's dealing with the designing a framework that can support the loads. So all you have to do is to design a system that when it is loaded, it will not fail. Whether it's a column, whether it's a slab, whether it's a beam, whether it's a footing, whatever structural element that you want to design, you have to make sure that you design a system that can actually carry the load. Okay, so structural design is shrouded under the following: load calculation, material selection, geometry and layout, analysis and testing. Now for the load calculation, it is important because you have to determine the weights and forces acting on the structure. Now, I usually tell people that whenever you are doing a design, a structural design, make sure to add all the possible weights, all the possible loads that will be coming on that structure. Whether it's a live load, whether it's a dead load, whether it's whatever load it is, whatever load you perceive, okay, will be coming on that structural member must be added. Now, if those loadings, those load calculations are not done properly, you will end up under designing or over designing, which will lead to structural failure. We're going to see that structural failure later in today's class. So for material selection, structural design entails choosing materials. Now we have different materials with which we used to build around this part of the world. We use concrete, we use steel, we use wood. We also have composite structures, combination of concrete and steel. Now, these materials are chosen based on their strength, durability, and cost. Okay, so we are going to get to acquainted with all this later in this class today. Geometry and layout. You have to design the structure, shape, and arrangement for stability and efficiency. This is very important. When you get a
Engineer Didon, please bear with me. Somebody said that there is no sound. Can we confirm, please? Can you all hear him?
Okay.
If you can hear him, show a thumbs
Yes,
up.
we can hear you loud and clear, sir.
Can hear you,
Yeah,
sir.
we
Can
can
hear
hear
you,
you
sir.
loud and clear. All right.
Okay, go on. Go on.
Can hear him.
Please, if you have an issue hearing him, that could be
Okay.
your internet. Just wait a bit. Yeah, go on.
Okay. Yeah. Okay. So that's what I was saying, geometry and layout. Now, as a structural engineer or a structural designer, okay, once the architect gives you an architectural drawing, you have to generate your what we call general arrangement, a GA, okay, showing where you want to place your columns, how you want to run your beams, and how you want to run your slabs and other structural elements. Now, this is very important because you can be given a design, and a design could be given to two people, and they will come up with two different arrangements, and those arrangements entails different level of stress. The last design is analysis testing. Now this is where a lot of mathematics and
Like his mic is not working, no.
I will check again. Hello, Engineer Edidion, please check. We couldn't hear you for some time, especially where you were explaining about those geometry and so forth.
It's like his network is bad.
Just wait. We'll figure that out now. Just give him a second. Just wait. Can you all hear me?
Yes, we can hear you, sir.
Yes,
Yes, I
can
can
hear
hear
you,
you. I can hear you.
All right.
a thumbs up or okay, okay. So the objectives of structural design, like I said, we have three core objectives.
Engineer Edidion,
Okay,
can you go back a
one is
bit
safety.
towards the bottom of the last slide? That was where we lost.
Okay.
Oh, oh my God. Engineer Edidion, please unmute yourself, please. Please bear with us. Get that sorted now. Sometimes it happens. I think he went off to come in again. So just let's give him a few minutes. Please bear with me. He's coming in again. You are all welcome. In the meantime, while he comes in, I can be talking. You are all welcome. Engineer Didong, are you there?
Yes, yes, yes.
Please continue.
Yes, so sorry, my network is quite horrible today. Okay, so let me share my screen. Okay, so if you can see my screen, kindly send a thumbs up. We can go ahead.
Yeah, I think
Okay, so I can go ahead. Yes.
your screen is just coming up. Really
So I
sure
was talking before the network issues about the geometry, and now I stressed on the importance of the general arrangement. That's what we call it, the general arrangement. Now, I gave an instance where you give a design to two different people and they come up with two different general arrangements. Okay, so the general arrangement may differ, and as much as it is differing, I mean, it's different. Okay, it also affects the loadings, it affects the stresses that are coming on each of the structural members. Okay, so your geometry and layout is also a key part.
I think should be network problem, right? Nothing is happening around here.
It is. Just bear with us.
Okay.
Just bear with us, please. I will make sure in the next one we are going to do, we'll make sure we optimize it. This is some things you notice when you come online sometimes. So we'll make sure we optimize better.
Nigeria wahala is all over. It's not just anybody's fault. It's the situation of the country. Nothing works in Nigeria. We are aware of that.
Just bear with us. Please. Mohammed is laughing.
But it's the truth now. Nothing works in Nigeria. Nothing works.
No, things work. It's just the way things are.
We are just managing the situation.
Just bear with us. Let him come in again. In the meantime, I was talking about I think I should be chipping this in between wherever they listen. So I was talking about our former structure of tutorial that we used to have, and I'm trying to emphasize the fact that I have found out that it needs to change, right? And I will definitely, by the time we finish this one, I will show you what we have done so far, based on the as regarding the change that we're talking about. Towards the end, I want to show that. So if you stick around, you'll get to know about it. But all we are saying is,
okay,
notice that some people, or due to time, some people are not actually like learning through the tutorial that we have, and it's a concern. So we're trying to find a way to make it better, make it easier, make it task-based, such that people can now learn per week and know that they, at the end of this week, they submit an assignment. So at their own time, they finish it and submit. Get the idea? I'm just giving you, this thing of the whole thing. But while that is going on, I want to ask you people, with what we have, do you feel or do you think learning software via video live classes like this, okay, is better than using video tutorial? Anybody can answer.
Can you come again? Can you come again with that question, please?
Engineer, good evening. In my own opinion, learning via video tutorial is good if and only if your first suggestion about assignment, weekly assignment will be introduced. It will aid us in trying to know that we have a task every week to fulfill. So it will also, now we are having network issue now. This network issue now will hinder some people.
Hello, sir. I'm sorry. I said, yes, for the question, sir. Hello?
Please,
Yeah,
Hello, sir.
if wait, Mr. Maris is still talking. Kelly, you have to wait a bit, please.
Okay, thank you. Thank you.
Mr. Maris, go on.
Now we are having, okay, sir. Yeah, thank you, sir. Now we are having network glitches. I believe this break in transmission will not pass the information very well. So if it's recorded and this weekly tax is being given, and whoever does not make it a point of duty that maybe you give that person maybe 2 or 3 weeks. You know, if that person fails the first week, fails the second week affected, that means that person doesn't want to learn. You know, if you want to learn something, you bring out your time. I believe it will help us to move ahead. Thank you very much, sir. That's my opinion.
Thank you very much. Mr. Daniel Okutu, can you contribute, please? Yeah, good evening. We can hear you. Go on. We cannot really hear you well. Can you speak up louder? Maybe you're wearing earpiece. You can remove that. Hello, Mr. Daniel.
Can you hear me? Can I?
Yeah, go on now. I think we can hear you.
Okay, I said my opinion is that I think that the other method of having videos to watch, it's more workable for me, because like this video, live video that we have in session, apart from the problems we have with the network, sometimes people might not have time to link up. Some people work even on Sundays, and they might miss it. And so, like the Plan Swift software with the videos, I really enjoyed it. I learned it on my own from the videos. So it gives you a time on your own to, go through it, learn it, ask questions. This one too is also good. It's just that one, this network issue. Two, not everybody may have the time now. Like I saw somebody on the platform saying if you could record the video and send, obviously that person doesn't have the time at that time when the session is going on. So for me, the other one is more preferable. I don't know about others, but that's my opinion.
Okay. Mr. DF Geo Limited.
Yes, thank you, Engineer Daniel. I think they've answered everything, but in addendum, I think to my own best opinion, the video is more best. Then I could remember there's a video I purchased, and that was last 2 years. I still have that video on my file. If I'm having any issue, I can easily go back to that video, rewatch that video, and correct myself. I think the video is more better, sir.
It's all right. We will continue. Okay, Mr. Emmanuel, but Ayuba has raised his hand. Can you talk while we? Emmanuel Pitako Ayuba.
Yeah, good evening.
Good evening. We
Good
can
evening,
hear
sir.
you.
Yeah. Well, I have a slight opinion, a different opinion than what was being offered here from the. I think both are good. Both are very interesting to to partake. You know, and why I say both are good. You know, this live video also helps us to learn from one another. It doesn't matter if you don't have the time; those people who have time can reconnect, and it helps us to learn from one another. Sometimes the direction the moderator or the facilitator of the video is going through might not be the route that somebody gets to understand and learn. And sometimes somebody may throw in a question, and that would be the light for that person, and there'll be understanding. So I think live video like this, live program like this is also good. The issue is that while we are doing it, we should be recording it like what we are doing right now. It should be recorded, the proceedings. So at the end of the course or of the teaching, the videos should be sent to members of the platform. That is how the video should be recorded, not on. It should be an interactive video that is recorded while the teaching is going on. At the end of it, then it should be sent to members of the team who are interested or who would have also been the live teaching but missed out. They should be sent that this is what took place when they were in their absence. So that's what I have to say, sir. Thank you.
Thank you very much, Mr. Emmanuel Ayuba. Our tutor is back, so we will come back to all these things later. So I noticed somebody is raising his hand. Isa Shiba. We will continue with you later. But let's go back to our training and finish up and then come back to this whole thing. Engineer Didom, you have the floor for now.
Okay, thank you very much. My sincere apologies for the on and off. Let me share my screen. Okay, so if you can see my screen, kindly send a thumbs up to be sure that we are all there. Okay. Okay. So as I was saying, these are the three core the objectives of structural design: safety, serviceability, and economy. Now, I said, I don't know at what point the network disconnected, but whenever you are doing your structural design, always have these three in mind. If you want to place a column, if you want to run a beam, if you want to run a slab, always have these three core objectives in mind. Is it safe? Is it functional? And is it economical? Okay. If you can hear me, kindly send a thumbs up so that I'm sure that we are all following. Okay, thank you very much. So apart from this, there are other objectives of structural design, okay, of which we're going to be seeing. But these, like I said, are the core objectives. The core objectives. Always have these three in mind: safety, functionality or serviceability, and economy. Safety, functionality, and economy. Okay, so there, like I said, there are other objectives of structural design. One is durability. Okay, the reason why you're designing is to design for longevity and minimal maintenance. Now, having this at the back of your mind will help you make some decisions. Make some decisions based on durability. And we have aesthetics, of course. You have to consider the appeal, the building's visual appeal, and how it fits with the surroundings. Okay, so you have to find a way, okay, to impute the building's appeal into your design. Okay, so that you don't just, for instance, if the client is envisaging an open space, okay, you won't just go and introduce a column at the middle, okay, unnecessarily, except it is ultimately compulsory that a column should be there. Okay, so you have to find a way to make sure that your structural design, okay, falls in line with the architectural design, so that there is a smooth transition, okay, so that the both designs don't go at loggerheads. You know, the architecture is saying one thing and the structure is saying another thing. Okay, so these are the objectives. As well, stability. Okay, you have to make sure that you have to take stability into consideration, preventing structural failure and excessive movement. Okay, so these are the objectives of a structural design. Someone will say, why do I need a structural design? You need a structural design to make sure that your building is safe. We just listed the objectives. Make sure that it is safe, it is functional, it is economical, it is durable, it is aesthetic, and it is stable. Okay, these are the objectives of a structural design. Later on in this class, we're going to see examples of structural failures. Okay, and these failures most of the times as a result of either inadequate or poor design, or poor consultations of the right professionals. Okay, you're building a structure that you know is going 2 or 3 floors, and you don't engage the services of a structural engineer. You don't engage or get a structural design. Trust me, that building is liable to fail in the nearest future. Okay, you may say the architect is experienced. Every profession has their own, you know, their own parts to play. Every profession has their own parts to play. The architect has his part, the structural engineer has his part, okay, and that goes for the rest of the other professionals, the electrical, the mechanical, and all of that. Okay, so you make sure that what I'm trying to do is I'm trying to paint to you the reason and the importance of a structural design for every building. Okay, to make sure that the building is, number one, it is safe for use, it is functional, it is economical, it is durable, it is stable, and it's also aesthetics. Okay, now going further, structural materials are the backbone of construction, determining a structure's strength, durability, and overall performance. Now, in order for us to achieve these structural design objectives, we need to use structural materials. Okay, we have listed the key structural materials used in buildings. You have the concrete, you have steel, you have wood, you have masonry, and you have composites. Okay, so these are the key structural materials used for structural designs. Okay, if you can all hear me, kindly send a thumbs up and a high five to know that I am communicating. Okay, thank you very much. Thank you very much. So now we are going to be discussing these structural materials, trying to look at the advantages and disadvantages. Okay, because as you are doing a structural design, you have to choose your structural material. Are you going to use concrete? Are you going to use steel? Are you going to use wood? Or are you going to use masonry? Okay, so we are going to look at the advantages and the disadvantages, more like the pros and the cons. Okay, so these pros and cons will help your decision to what material to use okay, now structural materials are also structural design to decide based on the advantages and disadvantages of each structural member. Okay, so below are the advantages and disadvantages of structural materials. Okay, we are looking at concrete first. For the advantage, concrete is durable, concrete is fire resistant, and concrete can be molded into shapes. For the disadvantages, concrete is heavy, concrete is prone to cracking, and concrete has low tensile strength. Okay, so we look at these pros and these cons, these advantages and these disadvantages, and this will help you, okay, make a decision on which structural material to use for your design. Okay, so going down to steel. Okay, for the advantages of steel, it has a high strength to weight ratio. It is versatile. It is recyclable. Under the disadvantages, it is susceptible to corrosion. It has high costs for maintenance. It has high cost of installation. Okay, now we go to wood or timber. For the advantages, it is renewable. It has an aesthetic finish. It is easy to work with. For the disadvantages, it is vulnerable to pests. It is vulnerable to fire, and it is vulnerable to moisture. Okay, the next structural material is the masonry, which is a block 9 inches, 6 inches, brick, and all of that. Okay, for the advantages, masonry is durable. It has low cost of maintenance. It has good thermal mass. And for the disadvantages, it is heavy, it is labor intensive, and it is weak in tension. Okay, so with these advantages and disadvantages of the key structural materials, you can have a fair idea of what structural material to use for your design. For instance, you cannot even think of using wood as a structural material for a waterlogged area, because definitely you know that wood, okay, is prone to has issues with moisture. Okay, so whenever you have wood, you don't want to have water close to it or moisture close to it. So that tells you that we can't use wood as our structural material. So you can now go ahead and decide, should I use masonry, should I use steel, or should I use concrete? Okay, so depending on what you are designing for, your site locations and all of that, that will help you. And also looking at the pros and the cons of each of the structural materials that we have listed will help you make a decision. Okay, so going to the next, we're going to be discussing who a structural engineer is. A structural designs, analyzes, and ensures the stability of structures like buildings, bridges, and dams. They work with architects and other professionals.
So
The other
we can't
professionals
really
could be
get
the mechanical engineer, the electrical engineer, the horticulturist, and other professionals.
Hello, can you hear me?
Can you hear? If you can hear me, kindly send a thumbs up or a high five. Okay, thank you. Okay, so a structural engineer designs, analyzes,
please,
and ensures the
some
stability.
some of the some of the explanation.
Mr. Kelly, can you hear me? Engineer Dylan, can you hear me?
We can hear you, sir.
Yes, I can hear you, sir.
Proceed, please.
Okay. Okay. Yeah, so a structural engineer designs, analyzes, and ensures the stability of structures like buildings, bridges, and dams. Now, a structural engineer works with architects and other professionals. The other professionals could be the mechanical engineer, the electrical engineer, the horticulturist, and all of that, other professionals that are involved in the construction industry. Okay, contractors and clients to create a functional and durable structure. Now, a structural engineer doesn't work alone. Okay, the structural engineer doesn't work alone. He works hand in hand when it comes to the building sector. He works hand in hand with the architects and other professionals. Okay, that's important to note. Okay, so I've listed out the roles of a structural engineer, either on site or off site. Okay, so number one role of a structural engineer is structural designs. Now, the role of a structural engineer is to create structural systems and elements, okay, that are safe, that are functional, and are economic. Okay, the structural engineer also carries out structural analysis, assessing loads, stresses, and stability using calculations and softwares. Okay, the structural engineer also, has a say in the material selection. Okay, and also the mix ratio. For instance, if you're using concrete, it's the structural engineer's role, okay, to make sure that the mix ratio goes with what is on the design. Okay, so that's also part of material selection. And then in a larger scale, selecting if it's going to be a steel structural material to be used, or masonry, or concrete, or wood. Okay, so that's also the role of a structural engineer. Another role is for safety checks. Okay, structural engineer has to ensure that designs meet safety codes and standards. The next role is collaboration. Like I said earlier, the structural engineer does not work alone. Okay, it's a teamwork. He works with the architects and other professionals, works with the contractors and clients. Now, another role of the structural engineer is problem solving. This is very key, very, very key. Okay, as a structural engineer, you should be able to solve problems on and off site. Okay, address site issues or design changes. Okay, if there's need to be a design change, you should be able to solve such. Maybe on site, maybe off site. Okay. Also, the role of a structural engineer is also documentation. By documentation, preparing drawings, specifications, progress reports, and all of that. Okay. And then for this class, the last role of a structural engineer is for inspection, to monitor construction, to ensure compliance with designs. Okay, so these are the roles of a structural engineer. If you can hear me and see my screen, kindly send a thumbs up or a high five so that I know we are all together. Okay, thank you. So next, we're going to be discussing structural failure and collapse. Structural failure occurs when a building structural system can't support applied loads, leading to partial or total collapse. It's no news that there has been a spike in the number of building collapse and failure globally. Okay, structural failure is deadly. As you can see, I have listed out the number of casualties, okay, for these select few cases, these select recorded cases of collapse, okay, and the causes of this failure will be looked at shortly, okay, but we are just trying to tell you that structural failure happens, and when it happens, the casualty is high. Okay, we have one in Tangat Mall collapse, that's in South Africa in the year 2013. 2 were killed, 29 were injured. Bayersdal Eco Estate collapse in Johannesburg, South Africa. 7 were killed. The Synagogue Church collapse in Lagos, Nigeria. 115 were killed. The church collapse in Uyo, Akwa Ibom State. In 2016, 100 were killed. Building collapse in Ikoyi, Lagos. 45 were killed. Building collapse in Kinshasa in the Democratic Republic of Congo in 2022. George Building collapse. I think this is in South Africa also. 33 construction workers killed. Now, this is to tell you the effect of probably not involving a structural engineer or using a poor structural design or not following your structural design. It is very, very tragic. Okay, so causes of failure in structures. We're going to be looking at some of the causes of this failure in structures, okay, so that we can find a way not to go there when we are doing our structural designs. The first here is design errors. Okay, this is caused by inaccurate load calculations or assumptions. I remember in the earlier part of this class, I mentioned load calculations, okay, which is key to a structural design. Now, if your load calculations are not done properly, okay, your analysis may be correct and your design may be correct in line with your load calculations, but in reality, it is going to fail. Okay, for instance, according to the codes for a residential building, and I'm talking about the British Standard Codes now, for a residential building, you have a life load of 1.5, okay? And in your calculation, your load calculation, instead of using 1.5, you decide to use 0.75, okay? That will mean whatever design you get will be less than what is expected, okay? And what that happens is that there is failure, okay? Either in any of the structural elements, there could be failure in any of the structural elements. So design inaccurate load calculations is a major cause for failure. I was privileged to be asked to look at a building which had visible, cracks, structural cracks, and after we engaged, we went ahead to chisel the affected structural elements to see what was actually the problem, see the reinforcement used. And we noticed that what was provided, okay, was the same as what was in the design, quite all right. But when we looked at the calculation sheet, we noticed that the load calculations were wrong, okay. For instance, they used a load that is meant for a residential. They used it for a commercial building, okay. So it caused issues. Yes, the analysis was correct, but because the load calculations were wrong, it brought about a wrong design, which led to failure, okay. So proper calculation of the load is very important. Okay, the next there is insufficient consideration of load combinations. So this is all entangled with load. Then poor detailing or connections. This is also very important. As a structural designer, you have to be able to do a proper detailing. Make sure that what your design is can be easily seen, easily read, and easily understood on the site. Okay, so your detailing has to be top notch. Okay, because you could go ahead and have a good design, good analysis, but then because of poor detailing, the people on site may not be able to probably see what you put and then just do anything, and that may lead to failure. And then the last here is inadequate structural analysis or modeling. Now, if you don't do the right model, like I told the people I taught on total structure, if you don't model correctly, you're going to have a wrong design, which will inadvertently lead to a failure. Okay, so we are going ahead. The next cause of failure is material defects. If you can hear me and see my screen, kindly send a thumbs up. So I'm sure that we are all coming along. Okay, thank you. So the next cause of failure is material defects, substandard materials or manufacturing flaws. Okay, this is very, very key, okay, in your design. I can remember in the class I taught on total structure, I told them about an instance where we're using reinforcement when you're designing, and your reinforcement steel in your design is 410 Newton per millimeter square. And then you go to the market, you buy your reinforcements, and then you go ahead and run your test, and you notice that some of those reinforcements are having strengths of 200 and something, 320, 315, 256, you know. So when you get substandard materials, it is a probable cause of failure. Okay, the next is incorrect material selection for the application. Okay, when you select the wrong material. For instance, like the instance I gave earlier, you are living in a waterlogged, you want to design for a waterlogged area, and the structural material you decide to choose is wood. That will tell you that that will not even last up to a year. You know, it's going to be eaten up by pests, it's going to decay due to moisture. Okay, so a proper and a correct material selection is also important to avert failure. Next is deterioration or degradation after time. So materials degrade and deteriorate depending on their standard and their level of exposure to the, to the weather and all of that. Now, the next cause here of structural failure is construction issues. Okay, deviations from design specifications or drawings. This is a very common issue of common cause of failure. Okay, where the structural design provides 3Y16, for instance, at the bottom for a beam, and then someone comes to site and from his own knowledge or whatever decides to use 2Y16. Okay, and it happens a lot of times in a lot of sites. Okay, you go and the client is trying to the client or the contractor is trying to cut corners. By cutting corners tends to deviate from the structural design. Now this is a major cause of failure. Okay, the next day is poor workmanship or craftsmanship. Okay, yes, when you don't have the right team, the right workers, you end up having issues with your delivery. Okay, if you have poor workmanship or poor craftsmanship, you're going to have issues with probably honeycombs, failures, deflections, and all that. Okay, but when you have the right team, the right workmanship, the right craftsmanship, then it saves you also from failure, structural failure. The next there is inadequate supervision or inspection. Okay, it's actually very important that for every site there should be a structural engineer there to help supervise and inspect to make sure that designs are duly followed in tandem to the codes and standard. Okay, also unforeseen site conditions. Okay, there are several times where a design is done And then when you go to sites, you see different site conditions. For instance, maybe the designer didn't even go to the site, and he uses a soil bearing capacity of 150 kilonewtons per meter square, uses that and designs. And then when you get to site, you notice that it's a very poor soil and it's having about 100, or even 75. Now, if that is noticed, the structural engineer or designer should be contacted immediately, okay, for further analysis to confirm. But most times they just go ahead and implement the structural design, and that leads to failure, okay? So the next cause of structural failure is overloading. Overloading, okay? When the buildings are exceeding their design loads or capacity. Okay, I'm going to give an instance. My firm was called upon to run an integrity test on a three suspended floor building. Okay, and in the process of carrying out our investigation, we noticed that initially this building was meant to go only one floor. Okay, but then the client at some point just decided out of nowhere to take it to 2 floors. So this is what we're talking about, overloading. Now the foundation that's already on ground was not designed to carry this much load, and now there's now an additional load. Okay, so that is another case of another cause of structural failure, when the design loads anticipated is exceeded. Okay, unintended use or changes in the occupancy. This is also important because when you're designing based on the life load calculations, it is based on the use of the structure. If it's a residential, it has a stipulated life load. If it's a commercial building, if it's a hall, if it's a church auditorium, whatever the case is, it has its own life load. Now, if the intended use of the building is changed, that means the loading on that building changes, immediately. Okay, and that affects, the structure. Accidental loads, yes, you have cases where there is vehicular impact, for structures that are close to the road. There are times where a vehicle could lose control and impact on the structure. Okay, that can also cause failure, because that load, that accidental load, that impact was not designed for, okay, when designing, was not taken into consideration when designing that structural member. The next is environmental factors. Weathering can also cause failure. Corrosion or degradation, natural disasters. All these can cause structural failure. If you can all hear me, kindly send a thumbs up or a high five to know that I am being seen and heard. So next we have foundation problems. Now this is another major, cause of failure. Okay, soil settlement or instability, inadequate foundation design or construction, water table changes or erosion. Okay, these are foundation problems. Now, if these foundation problems are not taken care of, okay, if they are not taken care of, they may lead to structural failure. Settlement is a very common cause of structural failure. If you have a soil that doesn't have enough, bearing capacity to carry, the load of the building coming on it, you tend to see settlements. Okay, So there are several things to do to make sure to attack soil settlement. You could introduce a different type of foundation, probably a raft foundation or a pile foundation, or you could introduce ground beams, to make sure that it helps to cancel out every form of differential settlement. Now, inadequate foundation design or construction. Okay, like I said earlier, there are times where designs are deviated on site. The structural design says use say 12y16 in the foundation pad footing, and then you go to site and the client is trying to, the contractor or the person constructing is trying to cut corners. Instead of using 16 10y16, goes to use 8y16 or something less, or 8y12 and all that. So that causes a great harm, and that makes it more prone to fail. Now, water table changes or erosion. This is also a major cause in the riverine areas. Okay, so those in the riverine areas have to choose their materials properly. If it's concrete, you have to um, know the grade of concrete to use. You have to know if you need to add any admixtures, to make sure that your concrete is can withstand all the changes in water and erosion and the saltiness and all of that. Okay, so you have to take all that into consideration. So that's part of your role as a structural designer. Now, the next is maintenance neglect. Okay, there are times when your building or your structure will always give a sign. There is always a sign. There's almost always a sign before a failure. Okay, there's almost always a sign. It could be a crack on the wall, a crack through the beam. There's always a sign before a total collapse or failure. Now, most times we neglect it. Okay, we try to say, this is just a small thing, it's not going to be too much, or you keep procrastinating, and before you know, one day it snaps and everything comes crumbling down. Okay, so number one, lack of inspection or repairs. Next is ignoring signs or distress or damage. Like I said, there are almost always signs. Okay, before a building gets to the point of total collapse or total failure, there are signs everywhere. It's just that we neglect the maintenance, we neglect our checks, to make sure that the structure is fine. So next is the inadequate upkeep or replacement of components. Okay, there are times where you need to make some adjustments. It could be repairing a crack, stopping it from extending and all of that. If maintenance is neglected, it is going to increase the possibility of a structural failure. If you can see my screen and hear me, kindly send a thumbs up and a high. Okay, thank you very much. So next, we are going to be looking at buckling, compression, and shear. Now, amongst others, these are the three major failures that happen in structural elements. Okay, you have buckling. Buckling is a structural failure where a slender member, like a column, suddenly bends or bows under compressive load, often leading to collapse. Okay, so you can see the diagrammatic representation here of buckling. Okay, when the load becomes more than the compressive load is more than the compressive strength of the structural element, buckling happens. Okay, so you can see how it bends. Okay, then we have compression. Okay, let's discuss on compression. Compression is a force that squeezes or crushes materials, causing it to shorten. Failure occurs when the compressive stress exceeds the material's compressive strength. Okay, so compression happens when the compressive stress coming on the structural element exceeds the material's compressive strength. Okay, so usually what happens is it reduces its height or its size. It compresses it. It's more like trying to hold agege bread or a loaf of bread, and you are pressing it. You put it in both palms, and then you're pushing them together. That's what compression. That's the idea of compression. Okay, so that causes failure. That causes failure. Okay, and that's most times that's because the loading on the upper floor, okay, is more than the loading in service in reality is more than what was anticipated for and designed for. That's when buckling happens. And then the last part is called shear. Shear is a force that causes a material to deform by sliding along a plane parallel to the force. Shear failure occurs when the shear stress exceeds the material's shear strength. Okay, so just like compression, this is a force, okay, it usually is parallel to the force. Okay, it's usually parallel to the force, and you notice it's usually diagonal. Okay, that's because the shear stress has exceeded the shear strength of the material. Okay, and most times for a column and for a beam, what takes care of shear is the links. Okay, the links. That's what goes around the main bars, the main reinforcement bars. Could be Y8, could be Y10, could be Y12. Okay, so that's majorly what takes care of shear. Okay, so now we have come to almost the end of today's class. What we are going to do next is we're going to be taking a case study of structural failures. Now, at this point, it's going to be an open discussion. Okay, we're going to be discussing as a class. We're going to look at several failures and then discuss on the possible failures, the possible cause of the failures, and how to remedy it. If you can see my screen and hear me, kindly send a thumbs up or a high five. Okay, thank you very much. Let me try to do this. Okay, so this is what we have. Okay, in a few seconds, I'll allow the house to make discussions to discuss on the reason why this has failed and the remedy to it. Okay, so if you have anything to say to that, kindly notify us so that we'll let you speak.
So, Adrian, can you share the picture? So, if you know the reason why this failed, what type of failure is this? You can tell us, and then tell us what caused it, and what is the remedy. You can raise your hand up, and then you speak.
Good evening, fellow engineers.
Mr. Maris, please, you need to raise your hand up first.
Yes.
For others, so we can be orderly here. The first person that raised his hand so far now is Kiwande Emmanuel. Please.
All right, thank you. Thank you, Mr. Friday. All right, this failure to me is a sheer failure, and the sheer failure from, I think it looks like a column to a bridge, if I see very well, and I think is about the failure of the material, especially I think the reinforcement that is used. Yeah, that's just what I can say for now. Yeah, that's what but the remedy, maybe other person can talk to us about the remedy. But I know that it looks like a sheer failure, majorly by the failure of the material. Yeah. Thank you. Thank you.
Mr. Maris, you can go now.
Good evening to everybody.
Good evening.
Yeah. Like the previous caller has said, it's a sheer failure, and it's also as a result of from the lesson we had that the design shear is lower than the proper shear caused by the load applied on the column, and also the material also. Maybe the stirrups used for the reinforcement is not adequate, or maybe it's not up to the designed material for that. The remedy for this is to take out this section of because it looks like a bridge, like you said, take out that portion and demolish this particular column and start it afresh. And also check the load, whether other columns has the same, if any of them is having any sign of failure. You can also do that in order to remedy that particular problem from occurring again. Thank you.
Thank you very much. Mr. Christopher Kilome.
Thank you for the opportunity granted. Can you hear me?
Yes, we can.
Okay. This is a shear failure. The shear failure is caused by the shear load, which is more than the strength of the shear material. For me, the remedy for this is to bring down the whole structure and start it afresh. Because with what I'm seeing here, there's no remedy. Trying to patch it up will result to more failure. So the solution is to bring the whole structure down and start it afresh. Thank you.
Mr. Godswill is raising his hand.
Okay, so just as every other person have said, it is shear load that caused this. So the remedy would be to demolish what is existing there, and then increase the shear strength by increasing the reinforcement, the stirrup reinforcement. Perhaps if it was designed at 250 center to center, maybe you can go to 100 or 150 just to increase the shear strength of the structure.
You can't increase it. This is a bridge foot now. How can you come on? What are you remedy here?
Well, let me talk. I have had an experience where, just like Edijon said, a certain building was having an issue, serious big issue. In fact, the reinforcements were rusting. And then when we went to investigate, we used this, I've forgotten the machine that you use, I've forgotten the name. I wish I can remember it. If you press, I think it does by destructive testing or something like that, or indestructive testing. Yes, that's the principle. So you use the machine and point it on the code.
Schmidt's hammer.
Yes. point it on the column, it will hammer the column for some time. Based on the reaction that comes from that column, we will know the amount, whether the reinforcement is good or not. Okay, so that was what we used, and we discovered the issue, that the reinforcement has rusted. Now, I know that this is a bridge. It can still be remedied. One way by default is break it down and start afresh. That's possible. But if it is only this column that has an issue, for instance, and there is no other column that has an issue, I think it is still possible. It is still possible to use jacks, because in that building we worked on, I know this is a bridge. I'm just trying to say that you can still hold the other two sides of the listen up with the rolling jack, with tiny spaces, and then work on this column and decrease, like Mr. Goswell said, decrease the spacing of the stirrups, because I think that's what caused the shepherd. This is my own view. I know that a bridge is different from a residential building, so it might not apply here. But in the case of a building, I think by using jacks, hydraulic jacks, you can be able to remedy the issue if that type of building. Does any other person have any contribution to make in this case? Yes, Emmanuel Obi is raising his hand. Emmanuel Obi, you can turn on your mic and speak.
Can you hear me now?
Yes, we can.
I just like everyone said, it's a sheer failure. But like you spoke last, I think it's not a complete total how will I put it? It's as if it cannot be remedied. I feel aside from what you suggested, something like for a bridge, you can do what we call a retrofitting. A retrofitting is like setting reinforcement around the field structure and building another pier or column to support that very area of the structure. So if you can bring a support on the two decks of the bridge, as it is a bridge, and then you make a foundation around it, a new foundation around it, then the reinforcement around it, and then cast a new pier or a column to support that very place. It will solve that problem. We've done something similar to that in one of the bridges, a railway bridge in the States, and it worked. It's more like doing a new thing on, not completely bringing it down, but having a new structure around it with adequate reinforcements that can support it. I believe it also can solve the problem.
Thank you very much. Does any other person have a contribution to make on this? We can clap for every person. Mr. Kelly is already clapping, so we can clap for as many as contribute. It's not an easy. This is one of the ways. This is one of the benefits of live classes, though. Just like I think it was Emmanuel Ayuba that said that this is one of the benefits of live classes. Mr. Dion, can you continue then? Engineer Didion, are you there? You didn't, you muted yourself. Okay, Edwin wants to speak. While we're waiting for Engineer Didion, Edwin, you can speak. Edwin Momanyi. I'm sorry if I'm not pronouncing the name well. Mr. Edwin, you can unmute yourself and proceed. Okay, okay, one more person is raising his hand. We confirm who that is. Mr. Kelly, you can speak. Kelly TTC.
Good evening, sir. Good evening, everybody.
Good evening.
Yeah, what I wanted to contribute was the previous question you asked. Me, I was suggesting let's do something like a video format, but let it be on a particular platform that would be like a class. Everybody to your to your category. If you are an absolutely beginner, you'll be at that beginner's class where you can be watching your video there. Then you can ask a question, and your answer will be given to you immediately by the same platform. So it will be like something like a website. So I don't know if this suggestion is good, because you see that video aspect. It's not that it's not good, but sometimes when you want to ask questions, you don't used to get reply on time, and sometimes I see most people don't used to. They are not always watching videos. So I think if we create something like a platform that is like a class, I think it will be better. So everybody to their categories, absolutely beginners, amateur, professionals. So the thing will be divided like that. So and a lesson will be also be given, like a assignment will be given.
Thank you very much, Kelly. I quite understand what you are saying in that case, and I like the idea. It's very, very good, right? It's also good somehow to have those that have learned to be with you in the same group, so that they can also help you. When somebody has gone through something and you ask a question relating to that, they can also help you. So we will find a way to put everything together and make sure it works. Engineer Didong, are you there?
Yes, I'm here.
Yeah, please, you can continue.
Okay. First off, I want to appreciate everyone that contributed. We all made very, very vital points. As we all said, this is a sheer failure, and as we discussed earlier, it's as a result of inadequate peer strength. Okay, from the peer. This is actually a peer, the peer of a bridge. So the sheer strength that was provided was inadequate compared to the sheer stress, that is coming on this peer. And the remedy, you could have several remedies. You could decide, like one person said, you could decide to completely demolish this and do a fresh one. You could also decide to try and work on this one. But all these remedies will be based, okay, on detailed reports. Okay. Number one, like I said, you have to make sure whatever remedy you're providing is safe. Okay, safety, like I said, is one of our core objectives: safety, functionality, and economy. So once you put those three together, you can come up with a remedy. You could decide, like our convener said, you could use acro jacks, to hold the bridge in place. Okay. After doing that, you can demolish some parts, the parts that has failed already, demolish it, introduce new reinforcements. You can do that. You can also introduce those jacks and completely demolish this pier, demolish it completely and then reconstruct it. Okay, that can also be done. And we could also do what we call retrofitting. What that means is after placing the acro jacks, putting the pier in place, you can now introduce a fresh layer of reinforcement. Okay, which will be designed for fresh layer of reinforcement around this existing pier, and you cast it. Okay, so it stays in place. So those are the possible remedies. Number one, complete demolition and reconstruction. Number two, you use acro jacks, hold still the bridge. Partial demolition, I think we can call it that. Partial demolition, demolish the area that has failed to show the reinforcements, and then you can replace the reinforcements. Make sure that the reinforcements you're putting, have enough shear strength, shear capacity to carry the shear stress coming on it. And then the third option is retrofitting. Okay, you use a fresh layer of reinforcements around the existing structure, around this existing pier. So you use acro jacks and then make sure you put the pier to be in place. See, it's already out of place. So if there's a way to put it back in place, you put your fresh layer of reinforcement, anchoring it into the existing one, and then cast and all of that. So like I said, the reason behind your remedy should be number one, safety. Okay. Number two, functionality. And number three, economy. Okay, so that's my take on this. I think we can go ahead and see the next one. Okay, so we have this as the second case study. I think we have about 5 case studies. So maybe find a way to reduce the amount of time you use to speak. So this is the second case study. The floor will be open. If you have any why you think this has failed, the reason for the failure, and your possible remedy.
You can raise your hand if you have.
So that can all hear me.
Okay, we have people raising their hands. Bamidele, Christopher is the first now. Christopher, can you speak once more? Or let me allow Bamidele to speak. Bamidele somebody, I've missed your last name.
Oh, sorry, it was a mistake. Sorry.
Okay. Christopher, you can go on.
Okay, thank you once again. Basically, this is a compression failure, and like every other one, the compression material lacks the strength to withstand the compression load, and that is why it is bulking. That's why this failure has surfaced. But if you ask me, like my previous recommendation, but considering the 3 most important aspects of structural engineering, if considering the three, but put in consideration the number one, which is safety. For me, when a failure occurs like this, I usually don't recommend fixing or amendment. I just recommend take it out, then start a fresh one. Yes, economically speaking, it's going to be expensive, but functionality wise, especially for the functionality, which also boils down to safety, for me, the solution to this is to start another one, start afresh. There is no need electroplating or whatever. Is to start afresh if a failure like this occur, which is compression failure. So that's my take on this structural defect. Thank you.
Mr. Damulawal, you can say something.
I hope I've been able to speak my mind here.
Yes, you are. You
okay. I don't recommend patching up, especially for the safety reasons and functionality, because the same load will still be there. So thank you.
Mr. Damulawal, you can unmute yourself and speak. Mr. Ademu Lawal, I think I didn't call it well the first time.
Okay, good evening, everyone. Thank you, my engineers. Can you hear me? Am I audible now?
Yes, you are.
Okay, just like my fellow engineer just spoken, is buckling due to the load capacity of the upper side, and that leads to the failure of the pier. However, it's a two-way thing. Just like he said, construction is all about the experience and possible safety solution. Number one, either there can be an introduction of a new pier from both sides by increasing the bearing capacity, that is the load carrying capacity of the pier, from a two-way side, having a kind of a cylinder from both sides of the pier. Maybe this particular one that is already failed, that has already buckled, there should be two other column or pier from both sides, while the buckling one is in the middle. Then you can do a support pier upward that can carry the load. But the first thing is you need to actually look at the design parameter of the field of the buckled pier to see, so that either you increase the load carrying capacity in terms of size of reinforcement, and then the size of the pier itself, either by increasing the size of the pier, increasing the size of the reinforcement, and then supporting it from base again. So economically, it's safer. There's nothing wrong with patching up. Patching up has to do with, when we talk about patching up, I think it's coming from another part, and it's not like a professional way of doing things. But if it's a profile solution, just like I said, in terms of you, engineer, looking at what leads to the failure, what was the initial recommendation to redesign. You redesign that particular buckle pier, I think it will provide a good safety, and it will be economical by making sure that the load carrying capacity of the new pier is increased, or you do it from two supportive sides, closer pier with the buckling at the middle, until the two is constructed. Is raised to with the help of a bearing that the upper part will rest on. Thank you.
Thank you very much. Mr. Kelly, no, before Mr. Kelly, Mr. Maris.
Okay, thank you. From the picture we are seeing here, it's called the buckling. The column buckled due to compression, and the possible reason is the cross section of the column, the design is not taken into consideration properly, and the spacing of the spirals also is another cause, and the material of that spirals used. The remedy here, on my own perspective, is this. They have to go back to the drawing to know what the group point that makes it one. Now, what you have to do is to complete this one completely. There's no need of the protein, kitchen, or whatever other remedies on that year. And now, the setting of the drugs has to be reduced. For instance, if it were to be 25, I believe it will reduce to 100 or 125. And also, the reinforcement number has to be increased. The reinforcement number has to be increased for this particular year. That's my solution, my own opinion on how to rectify this problem.
Thank you very much. Mr. Kelly, can you say something?
All right. Good evening, everybody. Yeah, this peer is a corporation, and like what Mr. Gideon said, he said three things that which was put together, which he said safety, management, like economical, and one other stuff. And everybody have been talking about safety. Like putting the rest aside. Yes, first of all, I know is safety. That's why our teacher said safety, economical. Because sometimes now, if you are breaking this thing down, if you want to bring this thing down and break it and scatter, you have to first of all pay for demolition. So to me, I suggest what the person that speak before this, Mr. Mari speak. He said you should do a two pair, one at the front, one at the back, at least to support. So it's new one, but that one will still be more what economical and better than just demolition and start doing another one. I think that one will be economical, safety to be still be good, because you first of all do calculate the load weight, reinforce it, then you now put it in both sides. At least that one is also a good idea that will work. So that's what I want to say. Thank you. Hello. That's everybody. No problem.
Sorry. Akiwanda, are you there? Akiwanda Emmanuel.
Yes, I'm here.
Please speak.
All right. From this, yeah, I think I'll talk about the solution first, which I think retrofitting can still be used to correct this, because if it's with what we are seeing here, the foundation is still okay. It's just that pair that have issues. So with experts, retrofitting can be used to fix the issue that we are seeing here. Majorly is just because the sheer capacity of that structural element is not good enough to withstand the load that we have on it. And maybe we should look at increasing the size. If it's going to fit to the foundation, we should look at increasing the size and every other thing that can be done to increase the sheer capacity of that structural element. And I'm sure that retrofitting can definitely solve it, by retrofitting done very well, that issues will be closed out. Thank you.
Thank you very much. Edidion, we'll do just last one, okay? But before then, I want to allow Solomon to speak on this one. Solomon, you are
hello. Good evening, engineer and colleagues.
Good evening.
I thank you for the opportunity to recap and relearn from you. Actually, at this point, we have spoken a lot about the reinforcement over there. But I would like her to also consider the aggregates, the aggregate sizes used, and then the quality of mixture that could also support the reinforcements. Please, are you hearing me?
Yes, you can. That's actually a consideration. For me, what I noticed was you will notice that those people, I think it looks like a what do they call it? A honeycomb situation.
Segregation.
They decided to come and pack it on the two sides by themselves. Take that picture again. Can you bring it back? It looks like a honeycomb issue. And then instead of them doing perfect work, they should do it like they just place maybe a reinforcement at the right hand side and then applied concrete on those two sides. And then without proper tying together with the whatever, I don't know what those people did there. And it turned into what it is. So I think that's what I see from my own end. The mixture matters, in fact. And if you look at it, you see that it just looks like a mat that is peeling off out of a column. Well, I might not be able to, confirm the whole thing, but I will allow God's will. God's will, you can talk about it, please, if you have another point to add to it.
So I think these things was discussed by the presenter, Mr. Didion. He just given us examples so that we can see it live.
Yes.
This is a compression failure. So the compressive load is higher than the compressive strength of the column. So it could be issue of concrete strength. So if it can be redesigned, given a higher concrete strength, and that will be able to carry the load. So I want to believe that he's just trying to move us to think, to see in line of what he has discussed, and then to provide solutions.
That's it. That's it, in fact. Okay. Thank you very much for your contributions. I don't know. Engineer Didong, are you here with me? Let me confirm. Maybe.
Yes, sir. Yes, sir. I can hear you now.
You can just push through the others quickly and then we conclude.
Okay. Let me share my screen. If you can see my screen, kindly send a high five.
You can see your screen. Go on.
Okay, so for this, like we have rightly mentioned, this is a failure due to compression. And like I would say, like I said in the previous case study, putting in mind safety, functionality, and economy. Okay, so you have different options like we rightly listed. So your decision as a structural designer has to be based on these analysis or these things brought up. Number one, we could retrofit. Number two, we could completely demolish and reconstruct. And I think those are the two options. And then the third one someone mentioned was to introduce another pier beside this in both direction, to the left and to the right, in order to reduce the load on this. Now, on this, I would like to let us know that most times when structures fail due to compression is obviously because the compressive stress coming on the structural element is higher than the compressive strength of the structural element. And when you talk about reinforced concrete, you always hear and know that concrete usually takes care of compression, and then the reinforcement takes care of the tension. Okay, so what that simply means is whenever there is a failure due to compression, okay, one way to remedy it is to increase the cross-sectional area, to increase the amount of concrete. Okay, so once the cross-sectional area is way bigger, then it can actually, the size of the pier, okay, if it's increased, okay, to a more bulkier size, it would counteract the compressive, stress coming on this pier. Okay, so like I said again, the three options are either to demolish, completely demolish and reconstruct, or partial demolition and patching up, or attending to the cracks and all that. And then the next is retrofitting, and finally you could introduce new piers just beside them to make sure they carry the load. Now, your decision as a structural designer is dependent, like I said earlier. You have to do a concise analysis, a concise investigation, trying out these options, okay, and then come up with your decision based on the peculiarity of your site. Okay, the site conditions in one person's site may be different from another. Okay, so you make sure that your site conditions, you check in relation with your site conditions. Okay, you come up with a design, or you come up with a remedial design that is both safe, functional, and economical. Okay, so for the next case study, this because of our time is already well spent. So this is as a result of buckling. Okay, you can see it's bent. Remember when we said when we discussed about buckling? Okay, it's buckling. Okay, that's because the compressive stress that's acting at the top here has exceeded the compressive strength of this structure, this column. Okay, so like we said earlier, the remedials are the same. It is either complete demolition and reconstruction, or partial demolition, or retrofitting, or introducing other columns to reduce the compressive stress coming on this column. Okay, so the next case study is this. I wish we had time. I would have loved us to discuss on this, because this is a combination of several courses. But since our time is well spent, as you can see, there is the shear cut. You can see the shear cut. I don't know if you can see my cursor. There's this is as a result of shear. Okay, and you can see it's cutting through the slab and the beam as well. Okay, so that means the shear around this location, around here, it has failed to shear there. And the second reason is settlement. Okay, this column, okay, has settled. The footing of this column has actually settled, and you see that's why it is now pulling.
Somebody said he's not seen anything. Just wait, it could be your internet. Go
okay, so I can go ahead.
Yes.
Okay. So the second reason, like I said, is because of settlement. Okay, obviously this column has settled, and because of the settlement, it is pulling all these other members downwards. Another reason for the failure is the discontinuity of this column. Okay, this column should have continued upwards, especially the fact that it's a corner location. So there should have been a column here. So that's another reason for the failure. That column would have helped tackle this shear cutting across this brick wall, because this brick wall, I guess, was not designed to be a load-bearing wall. Okay, it must have just been designed for as a partition wall, and carrying that shear, it's not able to carry it. So it needed, there's need for a column here. So I think those are the two causes, and also you can see the materials as well. Poor materials used, or poor workmanship, either poor workmanship or poor materials used. So those are the probable causes. Now for the remedy for this kind of critical case, I would actually suggest complete demolition of this area. You demolish the partition walls, okay, and then continue the column, and also check for any adjoining or closed column. Introduce a ground beam, okay, either introduce a ground beam or carry out underpinning in order to tackle the differential settlement of this column, and then extend your columns to, I think, the final floor, because this is a corner location, and it's important that a column should be there. So that once that is done, then proper workmanship, the areas that has failed, okay, that's visibly failed, will be chiseled and then reconstructed. Okay, so that's my take on this. But of course, we'll also run other tests. You can see serious cracks coming up on the column. Okay, so this could be as a result of a poor mix, or the reinforcement actually about to buckle due to compression. Okay, so for me, we demolish the column entirely and then reconstruct the column, taking it up to the next floor, and then reconstructing the brick wall or the block work. Okay, so this is a failure. As you can see, the building has actually collapsed. The building has given way. Okay, and that is as a result of poor or inadequate lap or development length. Now, this is very important. Most of the times, this is taken for granted. The lap length, especially wherever there is a joining, wherever there is the joining of reinforcement, has a higher probability for shear to occur. You can see this is as a result of shear. Okay, if you're using one reinforcement from the foundation all the way to the first floor level, then you don't have a problem with this. But when you have a situation where you want to have starter bars, from the foundation to just above the DPC, and then from the DPC to the first floor, you have to take note of your lap length. It is very, very important. That has been the reason for several failures, several building collapse, okay, because of poor lap length and poor stirrups. You can see the kind of tiny stirrups. This is like maybe less than Y8 even. You can see how tiny it is, and it's obviously inadequate. Okay, this is a joining and needs as much, shear reinforcement as possible, which are the links or stirrups. And you can see how tiny they are, and look at how they are spaced. Okay, so for our record, according to the British standard, the minimum lap length or development length is usually 40 to 50 D. 40 to 50, the D there is the diameter of the reinforcement. So if it's the Y16 reinforcement, you multiply 40, between 40 to 50. If it's 40 or you use 50, multiply by 16, Y16, which is the diameter, will give you the length, the minimum length of lap. Okay, the minimum length of lap. And also take note that that region where you're placing your lap should be properly, taken care of by shear reinforcement, by the stirrups, to make sure that the spacing around that lap is adequate. Okay, is adequate, to take care of the shear, because definitely once that structure is loaded, okay, is in service, there's going to be a high amount of shear there. And if your provision for shear at that location is inadequate, then you're going to have something like this. Okay, you're going to have something like this. And okay, this is the last case study. This is what we call honeycombs. This is usually as a result of inadequate vibration of the concrete, or a poor mix. Probably the coarse aggregate, the size of the coarse aggregate is actually too big, is above the minimum, and so it's the stones are finding it difficult to go down to the lower part. So you should as a structural designer or structural engineer, you should also make sure that the size of the stones are within the limits specified, so that once the concrete is poured and puckered or vibrated or tapered or tamped, whatever means of vibration you want to use, so that once that is done properly, then you're not going to have this issue. Okay, and with that, we have come to the end of this class. So I'll be handing over to our convener, Engineer Daniel, to take up from here. Engineer Daniel, over to you, sir.
Thank you very much. Engineer Didion, I'm really grateful for how well you have presented. Can we show a thumbs as in appreciation? We can share an emoji to appreciate Engineer Didion for helping out. Thank you very much. Looking at the three previous case studies he showed, one of them was on buckling, and you could notice that the beams, there were no beams there, and that was what led to, because buckling is as a result of slenderness of the column, and that comes due to the fact that a column is too long, longer than it should be in the building. Some residential building will have between 3.6 meters, between 3 meters to 3.6 meters. And in some cases, some people will build a column of 4 meters and then without proper beams, because without the beams, there won't be shortening. And that could have caused that issue. But that's about that. Now, I just wanted to use this opportunity to thank all of you for attending. And at the same time, I want to now tell you that, all this was, most of you were asking me, Engineer Daniel, we want to learn this. What is going on? And I will say, please wait. We have not arranged some things that we needed to arrange. And I want to now present what we have done so far. There has been a reason why I'm asking why live classes is better than this thing. And that's because of the fact that I am quite concerned of the modus operandi we had before. I have just come to notice that it's not working for many, and many people are busy. And that's why they have not been learning. So I will share my screen in a minute. The purpose of sharing my screen is just to show you, just to explain in detail, okay, what we have, because we are relaunching afresh the whole course, the whole courses. And then we want to show you what we have and what the improvement we have done and how we are going to go from now to make things easy. Okay. If you can see my screen, can you give me a thumbs up so I can confirm that you can see my screen? Okay, I can confirm that you all can see my screen. So I'm switching to a slideshow here. And what I have is improving our learning programs. So we have tried to improve it because of the challenges we noticed, and I'm going straight to the challenges. I will start by the observations I have made with respect to the learners, with some of you. One, so let me go. I found out that many learners struggle to complete the courses or apply it and apply the knowledge effectively. And that is because, one, most of the people that I've spoken to in the past only open the courses when they have a project at hand. And I understand, because that's when they are desperate. I don't know if you are in this category. I may not say raise your hand because I don't want you to identify. But if you are in this category, you should know what I'm talking about. And that's one thing I've noticed. Okay. And I also found out that a lot of us are busy. Okay. So it's difficult to sit down and learn. You come back from work Monday to Friday or Monday to Saturday. And when you come back in the evening, you're already tired and somebody is tearing you the other side. Your children are asking for school fees. Another set, landlord is saying house rent and so forth. Some people, their car is disturbing. Busy all around. I understand. And another thing we also notice is that this method of watching a video and learning is not what many people are used to. I don't know if I am wrong by saying that. We have been brought up to be using, the teacher is there, and then he or she is teaching you, okay? And you can ask questions in the process, right? Now, COVID came in, and then that was 2020, and there is an introduction of, though video lessons has always existed, because I used video tutorials as early as 2013 when I was in the university, but it became popular during COVID. Many people now have to learn via video tutorials, okay? And I don't know, at this point I raised about the unfamiliarity of the video learning. I don't know, is it making any sense? Like where we have been used to learning via classes, and then we are now being conditioned to learn via video tutorial. Am I making sense by this observation? If you think I am making sense, can you signify by thumbs up? If just let me know if I am making sense or not. Okay, so this is one observation that we also noticed. Many people are not used to that. So many people, on the other hand, many people are used to classroom method of learning, and they may not have the time or self-discipline to learn through video tutorial, especially with the fact that they have to learn when they are tied with the project. So this is the problem I noticed on the side of the learners. Now, the problem I noticed on our own side, which is we providing the training, I found out that the training we gave you, we didn't even give you assignments. There was no way to test whether you understood what was being taught or not. Right? That's one. Second one, the contents are not organized. Right? So we just, what was our process? Our process was, you make payment, for instance. Once you make payment, you get access to download the software, give you the link to download the software, and maybe and tell you to call us when you are willing, when you are ready to install, so how you can install it. And then we also give you access to the video tutorial, and then you can keep it at your own distance and watch at your own time. So it's not organized as to say, oh, it's step 1, step 2, step 3, step 4, step 5, like that. But it's not structured, meaning, okay, you should be able to finish this in the first week, just 2 videos. You should be able to finish the next 3 videos for the next week. You should be able to finish the other one, and you should do this assignment after finishing this video. You know, we didn't do that structure. Did you people notice all these things? So that was how we were operating before. And I'm happy coming out to say it because this is what I noticed, and this is, you know, and there is no capstone project. So most people now might have learned, and I didn't know they learned because I didn't give them any project that they return back to me and say, oh, we have done this completely. Look at what we did, and we give feedback. So there was no such thing. And I accepted this is my own problem as a result. And no certification, meaning there was no certificate in line for many people that are going for jobs. So no certificate that will motivate people to want to learn. You know, when you have a goal, I say you are going to get this certificate at the end of, and you are being followed through, you know, you went through all the assignment, went through the project, and then you are certified at the end. At least you get a reward for, you feel that there's a reward at the end that will help you, which is one thing we didn't include. And I accept it. You see, I'm being plain and open. This is one of the challenges we had. This is one of the problems we have with our first method of training. So, and we wanted to make a change. So, we have 2 solutions to this. A lot of people have mentioned they have no time, which I understand. In fact, that is the primary problem for many people in these shoes. Because if somebody is not a contractor or is not doing a job, that means the person is a student, and the student has all the time. But people here are mostly working class people, and time is sometimes you feel like there should be 48 hours in a day so you can be able to finish up what you have. So that's why we brought these 2 solutions. One is a structured, we are still going back to the video tutorial method, but structured in the sense you have in a week, okay, you have to watch just these 3 videos and do the assignment, and you should submit the assignment 2 days after, you know. So that week it is given to you. You watch that video and that's it. Next week you watch the other one. Before you know it, you finish. You finish up with the video. So that's about that. That's the first one, first solution. And this first solution, we decided to tie it to several other things to make it easy for us. And I'm going to open that segment now. First one is structural video distance. So in order to answer to all these things, and in order to be able to, how do I say, control what is being shared in the group, because these spam issues of people, you'll be in a group and somebody would say they have hacked my account and so forth, and spammers will come and be disturbed. Some scammers will now be picking other people's number and calling them. That was now, in order to avoid all these things, that's why in our website, we built something that looks like a social media platform. Okay, but that social media platform is tied to the courses only. Look at how it is. I have shown some people this one before, but this one is the normal page, which is not where I'm talking about. This is the place I'm talking about here. African Consulting Society Plus. Nobody is here. I'm the only person here for now. No post is here. So, but what we have done is link the courses to this particular community. such that if you are in this community or if you're in this group, this is like Facebook group. If you're in this group, you'll be able to access all these courses that are here under it. All these courses that are here. And then in order to show you what I mean by the organization of the training, making it structured by weeks, I'm going to open one of the courses. Let's do this one. This is Complete Lumion Masterclass, right? Then I'll go down here. You can see it's structured. Week 1, getting started with scene familiarity. You only have to watch 3 videos and complete the assignment. If you don't finish this video, for instance, you can't go here. And if you don't finish this one, you can't go here. And if you don't finish this one, you can't do this assignment. And if you don't do this assignment, you cannot go to the week 2. And in the week 2, we just have 1 video. Yeah. And it's just 6 minutes, for instance. You see these videos here are 2 minutes, 2 minutes, and so forth. Now, if you come down this way and then go to week 3, the same thing applies. Let me show you in practice. If I click start learning, it might allow me to click enter. It might allow me to start learning or jump anyone because I am the admin. I'm the one that created it. But if somebody else as a student comes in and tries to jump anyone, he wouldn't be able to do that. Now, some of you might say, oh, but it's better to watch via the one you saved on your laptop. Yes, I agree. It's better. You don't have to spend that again to watch it. But how will I know that you have completed? And how will I be able to award you the certificate if it is in your laptop? Right? And then how will I be able to know? How will I be able to confirm that how am I sure that something will not happen to that laptop tomorrow and you will no longer have access to the software, or you no longer have access to the videos, and you have to come back to me and cry and say, Engineer Daniel, I've lost access to the video. I know how many people that have said that. That's why we moved everything to the website. Now, some other people will be like, it will be costing me a lot of data to learn this thing. To be frank, the videos here are based on YouTube. I uploaded the videos on YouTube, but my platform has its own player that overshadows YouTube. So you wouldn't even know that it's YouTube. But if you can watch videos on YouTube, you can watch on this platform with ease. One thing I wanted to do was to make it in such a way that you can download, just like YouTube downloads into YouTube app, and then you can watch offline later. But when I checked the money to do that one, I just shut my mouth and I bowed out because it was very expensive. The people that I informed about it were trying to charge me around $20,000, and I didn't have it at the time. So that's about the first method. Okay. Can you all hear me? If you can hear me, can you signify by the thumbs up?
I can hear you, but it's just cracking. That's all. That's the problem.
It's just cracking. No problem. I will also talk about it again in the group.
Anyway.
But so that is what we have. Now, that's the first one, which is this one. Structured video tutorial program. So that's what we do.
Network is frustrating everything.
Yeah, can you hear me? It's all right. I will find a way to resolve.
We are hearing you. Go ahead, first.
Okay. Mr. Goswell, you have a question.
Yeah, sorry. Some people are leaving the program already, and this is almost this is 9:30. Many of us are going to work tomorrow. When are we ending this seminar, please?
Okay, what happens is this. What I will do is, can you give me 10 minutes to round up? All right. And then I'll go back to the groups to, introduce the whole thing afresh, if that's okay.
Okay.
All right. 10 minutes. I don't want to cross 10 minutes. This is 22. So 32 listen, and I'll be done. Okay. The second one we talked about now was the structured life classes, which is what we are using now. For instance, though internet is still kind of giving issues, but it also can help us in a way. This one allows you to come and learn weekly. Once a week, you come in and you learn. So this is one of the things we have done with structuring the whole thing. And then let's now go deeply into this. I will go through it complete, and then I think I've explained most of them. For the structural video tutorial, for instance, you will have the broken weekly, which I've shown you, assignments included. Then you'll also have instructor feedback on submissions, right? So that as you submit the assignment, the instructor will give you feedback in the platform. And there's an accountability listing on the community, which is just this one, for instance. The accountability stuff is here, sorry. Here, you submit the assignment and come here and submit it again so that we can get people to know that someone is going through or someone is completing the courses ahead. Now, so let me go back again. 10 minutes. Next one is weekly Q&A section. Then we have a kind of a gamification process that rewards every learner for watching videos on the platform. Okay, so that's what this one is. And the reward can now be used as a partial purchase for any other thing you want to buy on the platform in the future. I can explain how that, but let me just make sure I stick to my 10 minutes, right? Then you'll also be able to have access to advanced courses in the future and monthly design challenges that will help you with other things. Then going back to the other method, which I mentioned, the structured life classes, it's the same thing we explained, weekly assignments and continuous. If you compare the two of them, you see that this was our old program, how it was. And this is the new program that we have and what we are planning to start with in the process. So at the end, I believe that with this method, we'll be able to achieve consistent learning rates, and people can complete their courses, and people can be certified to have the skills required and then have the certification at the end. So I don't want to push ahead because of lack of time, right? It's already this, I don't want to hold you down. So I will give more details about that in the different groups. I just wanted to introduce it briefly to the people here, because not all of us are here, definitely. So anyone who is interested or who would like to, know more about it from among you, we can talk about it later. All right. So thank you very much for attending. Thank you for the opportunity to learn. Next week, we'll be starting with another introduction because I want to break it down. I don't want to just take structural. No, I want to break it down as next week will be architectural design, introduction to architectural design. The upper one will be introduction to bill of quantities, and the fourth one will now be interior design, right? So I don't want to waste anybody's time, all right? Next month, we'll also go to the next topics and so forth. And then from there, we can match up with whatever we have with our courses. But my goal is just to make sure everybody learns at the end, all right? Thank you very much for attending. I don't want to hold you more. I have only 5 minutes. And have a nice evening. Have a nice day. Thank you.
Thank you very much. I really appreciate it as well. I appreciate your time.
Yes. Mr. Moses, you are raising your hand. If you don't have a contribution, you
Thank
can say
you
it.
so much. Thank you. Thank you so much.
Thank you very much.
Yes. Some
Hello?
people are raising their hands. So if you have something to say, you can say it while others are doing. No problem.
Hello, engineer.
Yes.
Yes, I just joined late, so I wanted to find out, is there a recorded one which we can access later?
Yes, there is.
Oh, okay. Okay, thanks.
Thank you very much for giving out your time to appreciate so much.
Thank you. Mr. Christopher, you're raising your hand.
Yes, sir. Yes, sir. Yes, sir. First of all, thank you and everyone that have stayed tuned. Please, for personal reasons, this is my first time I've actually joining a live tutorial. I've not really been following, so I don't know. Maybe I should contact you privately on the way forward so I can catch up with others.
It's all right. You can reach out to me and then we'll see how we proceed.
Okay. Thank you. Thank you.
Thank you. Mr. Godswill, you are raising your hand. Okay. Thank you.
Yeah, I just want to thank you. We'll be looking forward to when you read the written. I don't know if you're going to do that. So, of course, we know it will cost us something. So, I don't know. This structural analysis now, detail analysis. When is it supposed to kick off? Is it after the presentation of the various courses that you have available?
No, I will present everything, the relaunch of the course. I'm going to present it in the groups after sharing this video so that everybody will now get to know what is involved and how it is going to be. Whether you want to continue with the video tutorial method, fine. Excuse me, or whether you want to continue their live classes, we will get to know. All right. Thank you very much.